Hello there, and welcome to the Cosmic Lullaby channel. In the vast, silent theater of space, a quiet drama unfolds. It is a story written not in human language, but in the slow, inexorable language of gravity. Its protagonists are the moons. These are not merely passive companions, but dynamic worlds that wander and drift around planets, both large and small, profoundly shaping the systems they inhabit. They are the silent partners in the cosmic dance, stirring atmospheres, shaping the rhythmic pulse of tides, and concealing profound secrets deep beneath their alien surfaces. For centuries, we viewed them as simple points of light, fixed and unchanging. But we now understand they are archives of cosmic history, and perhaps the cradles of our future. Some are ancient and heavily scarred, silent witnesses to the violent birth of our solar system, their faces a permanent record of billions of years of cosmic history. Others, however, are unexpectedly restless, worlds alive with the raw energy of volcanoes, geysers, and continents of shifting ice. Our own moon, the familiar face in our night sky, is merely the prologue to this grander narrative. Farther out, in the cold dominion of the gas giants, we find worlds that defy easy classification. There is Titan, a moon with vast, dark seas, not of water, but of liquid methane. There is Europa, whose placid, icy shell may hide a global ocean containing more water than all of Earth's seas combined. And then there is Enceladus, a tiny moon that sprays shimmering fountains of water and organic molecules into the void, a constant broadcast from its hidden subsurface sea. To know the moons is to begin to understand the hidden architecture of our solar system. Their forms are as varied as their compositions. A natural male narrator with a warm, friendly tone. Fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. Use pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. Tonight's journey is an intelligence briefing on these quiet companions, an analysis of their past, their present, and their critical importance to our future. Let the noise of the day recede. Let your breathing slow, and allow the quiet, gravitational rhythm of these worlds to carry you forward. Our story begins with a subtle yet profound act of separation, a slow, ongoing divorce that is reshaping our own world. Earth's moon is gradually escaping our planet's gravity. Year after year, it drifts approximately 1.5 inches farther away from us. This is not a random act, but a direct consequence of fundamental physics. It happens because the Earth's rotation, a legacy of its formation, relentlessly stirs the oceans into tides. These tidal bulges, both in the water and the solid crust, create a gravitational friction that transfers rotational energy from our planet to the moon. This energy exchange has two powerful effects. It gives the moon a slight orbital boost, nudging it ever so gently outward. And it acts as a brake on our own planet, causing its spin to slow. This simple, persistent process means that the sky of our distant past was dramatically different. Long ago, the moon hung much closer to the Earth. It would have appeared colossal in the sky, far larger, far brighter, a powerful and dominant presence in the lives of the planet's earliest organisms. Its gravitational pull would have been immense, creating savage tides that swept across the continents. It also means that in the deep future, our descendants will inherit a very different world. Earth's days will continue to grow longer as the planet's spin slows down, a process that will eventually lead to a day lasting over a month. The moon will be a smaller, dimmer disk in a distant sky. Though this process is incredibly gradual, unfolding on a timescale almost too vast to comprehend, it is a stark reminder that nothing is static. Even something as seemingly constant as the moon's orbit is quietly, relentlessly changing with the passage of time. The sky we see tonight is a temporary arrangement, a single frame in an epic film. It is not the same sky our most distant ancestors gazed upon, and it will not be the same one our descendants inherit. This slow departure is the first clue that the relationship between a planet and its moon is a living system, one of constant exchange, evolution, and ultimately of an inevitable final separation. The image of the moon as an eternal, unchanging satellite is a powerful illusion. For billions of years, it was not the silent, airless world we know today. There was a time when the moon breathed. Deep in its past, a ghost of an atmosphere clung to its surface, a fleeting chapter in its long history that is only now being fully understood by modern science. This ancient air was born from fire. Shortly after its formation, the moon's interior was a cauldron of molten rock and radioactive elements, a reservoir of immense heat. This energy drove widespread volcanism on a scale that dwarfs much of Earth's own volcanic history. Across its surface, great fissures opened and volcanoes erupted, not with ash and smoke, but with vast plumes of gas that billowed into the vacuum of space. For a period lasting tens of millions of years, the outpouring was so immense that the moon managed to hold on to a thin but very real atmosphere. Composed likely of carbon monoxide, sulfur, and water vapor, it was perhaps 100 times thinner than Earth's modern atmosphere, yet thick enough to create pressure and weather on a world we now consider inert. But this nascent atmosphere was born into a kingdom too weak to hold it. Lacking a global magnetic field to shield it and possessing only a fraction of Earth's gravity, the moon was defenseless against the relentless solar wind, a constant stream of charged particles from the sun. Over millions of years, this solar radiation stripped the gases away, molecule by molecule, bleeding the atmosphere back into space and leaving the moon bare and exposed once more. Yet this temporary atmospheric event was not without consequence. It left behind a legacy of profound strategic importance, one that is shaping the geopolitics of the 21st century. Scientists now believe this ancient, transient atmosphere played a critical role in transporting and trapping water molecules across the lunar surface. As comets and asteroids delivered ice to the moon, the atmosphere allowed water vapor to migrate from sunlit areas and settle into the permanent shadows of craters at the poles, where they remain frozen even now. These reservoirs of water ice are no longer a mere scientific curiosity. The overall moon is now viewed as the most valuable resource in near-Earth space. For nations and private corporations alike, this lunar water represents the key to a sustainable, long-term presence beyond Earth. It can be harvested for drinking water and breathable oxygen. More importantly, it can be split into hydrogen and oxygen, the two primary components of modern rocket fuel. The existence of this resource fundamentally alters the economics of space exploration. A refueling station on the moon would dramatically reduce the cost and complexity of missions to Mars and the deeper solar system. It transforms the moon from a simple destination into a critical logistical hub, a cosmic gateway. This realization has triggered a new space race, one not for flags and footprints, but for resources and strategic position. The United States Artemis program, China's Chang'e missions, and the ambitions of Russia, India, and private entities like SpaceX are all increasingly focused on the lunar South Pole, the very location where this ancient water ice is most abundant. The ghost of the Moon's long-dead atmosphere has, in effect, laid the foundation for the future lunar economy. When we look at the Moon, it is easy to imagine it as a relic, a world whose story is over. Yet its past tells a far more dynamic story, a time when it briefly breathed before falling silent again. And in that silence, it preserved a resource that now promises to fuel humanity's next great leap into the cosmos. The elegant, spherical shape we associate with celestial bodies is a privilege of mass. It is a form dictated by a world having enough gravitational power to overcome its own material strength, pulling itself inward until it achieves hydrostatic equilibrium, a perfect sphere. But not all moons are granted this status. Scattered throughout the solar system, particularly in the chaotic asteroid belt and in the retinue of the gas giants, are countless smaller bodies that lack this gravitational authority. They remain as they were formed, irregular, lumpy, and asymmetrical, their shapes telling a story not of elegant physics, but of a violent and disorderly past. These are the so-called potato moons, cosmic fragments that offer a raw, unfiltered glimpse into the building blocks of planets. Mars's moon Phobos is a prime example, a lumpy, misshapen body that looks more like a captured asteroid than a true moon. Its surface is dominated by grooves and craters, a testament to a long history of impacts and internal stresses. But perhaps the most visually striking examples orbit Saturn. The tiny moon Pan, which carves a gap in Saturn's rings, resembles a piece of ravioli or a miniature flying saucer, an astonishingly odd shape for a natural object. This bizarre form is not an accident of birth, but a result of its environment. As Pan sweeps through the rings, it accumulates a steady stream of icy particles that build up around its equator, creating a prominent ridge that gives it its manufactured look. Another of Saturn's moons, Hyperion, is so porous and pockmarked with deep craters that it has been compared to a giant sponge tumbling chaotically through space. These peculiar shapes are more than just cosmic novelties. They are invaluable scientific data points. Their irregularity confirms that they were never massive enough to melt and reform into spheres. Instead, they remain as jagged, bumpy, or disc-like artifacts, reminders of their chaotic and often violent origins. Some were born from the debris of larger collisions, the shattered remains of worlds that did not survive the solar system's brutal formation period. Others were once wandering asteroids, captured by the immense gravitational pull of a gas giant and forced into servitude. Their silhouettes, almost playful from a distance, tell a story of fragmentation and accretion. While the giant spherical moons feel like fully formed worlds, these smaller irregular bodies feel like the leftovers, the raw materials from the great construction project of our solar system. From a strategic perspective, these small bodies are also objects of immense interest. Their primitive, unaltered composition makes them pristine samples of the early solar system. A mission to land on and retrieve material from a moon like Phobos would provide more insight into the origins of the planets than a dozen missions to geologically active worlds. Furthermore, their low gravity makes them relatively easy targets for robotic and eventually human exploration. They could serve as natural space stations or mining outposts, rich in the same raw materials, water ice, carbon compounds, and metals that formed the planets. They are not just historical curiosities, but potential resource depots scattered conveniently across the solar system. Their quirky forms are a direct link to the past, a physical record of a time when the space between planets was a crowded, hazardous construction zone, filled with the fragments and rubble that would one day coalesce into the worlds we know. Beneath the cracked, frozen crust of Jupiter's moon Europa lies something truly extraordinary. a discovery that has fundamentally reordered the priorities of space exploration and positioned this small world as a primary target in the search for extraterrestrial life. Hidden from view is a global liquid water ocean, a colossal unseen sea whose existence is now supported by an overwhelming body of evidence. The overall models based on data from the Galileo and Voyager missions suggests this ocean is not a minor feature, but a vast body of salt water that could contain more than twice as much water as all of Earth's oceans combined. This simple fact is a paradigm shift in our understanding of the cosmos. It tells us that liquid water, the essential solvent for life as we know it, is not exclusive to temperate, Earth-like planets orbiting close to their stars. The persistence of this ocean in the frigid outer solar system, far from the sun's warmth, is a testament to the immense power of gravity. Europa's ocean remains liquid not because of sunlight, but because of a relentless gravitational tug-of-war. Jupiter's immense gravity constantly stretches and flexes Europa's entire structure, generating tremendous frictional heat deep within its core. This process, known as tidal heating, is what keeps the hidden sea from freezing solid. The Moon's surface bears the scars of this constant internal motion. It is a chaotic landscape of lines, cracks, and long curving ridges, the visible hints of shifting ice plates floating above the dark, hidden sea. This is not a static, frozen world, it is a geologically active body, its surface constantly being reshaped from below. This discovery has elevated Europa from a point of scientific interest to an object of profound strategic importance. The central question is no longer whether an ocean exists, but what lies within it. The leading hypothesis, and the one driving billions of dollars in international investment, is that Europa's ocean floor may be dotted with hydrothermal vents, similar to those found in the deepest, darkest trenches of Earth's oceans. On Earth, these vents are oases of life, supporting complex ecosystems that thrive in total darkness, fueled not by sunlight, but by chemical energy pouring from the planet's interior. Scientists imagine that on Europa, these vents could be mixing warmth and minerals into the water, creating the perfect chemical soup from which life could arise. For this reason, Europa is now considered one of the most promising places in the entire solar system to find living organisms beyond Earth. The quest to confirm this has become a new space race, defined by a singular goal: to reach and sample Europa's ocean. NASA's Europa Clipper mission, set to launch in the mid-2020s, is designed to perform dozens of close flybys, using sophisticated radar to map the ice shell's thickness and confirm the ocean's depth and salinity. Following it, the European Space Agency's JUICE mission will also study Europa, adding to a growing international focus on this singular world. The ultimate goal, a lander or a submersible cryobot that can melt its way through miles of ice to reach the ocean, represents one of the greatest technological challenges in human history. The stakes are immense. The discovery of even microbial life in Europa's ocean would be the single most significant scientific discovery ever made, fundamentally altering our perception of our place in the universe. Beneath its silent, barren surface, Europa hides a world that could be teeming with untold possibilities. It is a locked vault, and the nations of Earth are now forging the keys to open it. In the grand strategic landscape of the outer solar system, one world stands apart. It is a moon that behaves like a planet, possessing an environment so complex and so strangely familiar that it has become a central focus of astrobiological research and long-term resource planning. This is Titan, Saturn's largest moon. It is a world shrouded in a thick orange haze, its surface secrets hidden for centuries until the arrival of our robotic emissaries. What they found there was revolutionary. Titan is the only place in the universe beyond Earth known to host stable bodies of liquid on its surface. But this is a world built on an entirely different chemistry. Here, the rivers, lakes, and vast dark seas are not filled with water, but with liquid methane and ethane, hydrocarbons that exist in a liquid state in Titan's cryogenic temperatures. This is not a static frozen world. Titan has weather. Above its icy surface, clouds of methane drift and gather, and from them rain falls, carving channels and riverbeds into the landscape. This alien hydrological cycle perfectly mirrors Earth's own water cycle, but with organic compounds instead of water. The result is a landscape that is eerily recognizable, yet profoundly alien. Imagine standing on its surface, beneath an orange, hazy sky. The air, far thicker than Earth's, is composed almost entirely of nitrogen, pressing down with a palpable weight. On the horizon, shimmering seas of liquid natural gas stretch for hundreds of miles. This strange, parallel Earth presents one of the most compelling scientific targets in existence. Its complex cycle of rain and rivers, driven by alien chemistry, may be fostering organic processes similar to those that sparked the genesis of life here on Earth. For this reason, Titan is often referred to as a prebiotic Earth in a deep freeze. It is a natural laboratory for studying the chemical pathways that can lead to life. While Mars may have had life and lost it, Titan may represent a world stuck in the crucial step just before biology begins. Understanding its chemistry could unlock the secrets of our own origins. This scientific promise was what drove the historic Cassini-Huygens mission, a joint venture between NASA and the European Space Agency. In 2005, the Huygens probe detached, descended through the thick atmosphere, and made the first-ever landing on a world in the outer solar system. For a brief period, it transmitted data and images from an alien shoreline, revealing a landscape of rounded ice boulders shaped by liquid flows. Today, the strategic importance of Titan is growing exponentially. Its vast reserves of liquid hydrocarbons represent, in theory, an energy resource that dwarfs Earth's own proven reserves by orders of magnitude. While currently beyond our reach, this fact positions Titan as a long-term strategic asset of almost unimaginable value for a future spacefaring civilization. This potential is driving the next generation of exploration. NASA is currently developing the Dragonfly mission, a revolutionary concept. A dual quadcopter, a nuclear-powered drone designed to fly through Titan's dense atmosphere. It will hop from location to location, sampling diverse materials from craters, dunes, and riverbeds, analyzing the building blocks of life on site. Furthermore, Titan's thick nitrogen atmosphere offers another critical advantage: powerful radiation shielding. Unlike the Moon or Mars, where deadly solar and cosmic radiation pose a constant threat, Titan's surface is well protected. This makes it, in some respects, a safer, long-term destination for robotic and perhaps, one day, human outposts. Titan is therefore a world of profound duality. It is both a window into our planet's primordial past and a potential resource key to humanity's deep space future. A place that feels both strangely familiar and utterly alien, a frozen world with seasons, weather, and landscapes sculpted by a liquid utterly unlike our own. Among Saturn's extensive family of moons, a tiny, unassuming world has emerged as one of the most dynamic and scientifically profound objects in the entire solar system. At first glance, Enceladus appears to be just another small, ice-covered satellite, barely 300 miles in diameter. It shines with a brilliant, almost pure white light, its surface reflecting nearly all the sunlight that strikes it, making it one of the brightest objects known. For decades, it was considered little more than a frozen, dormant rock. But this quiet appearance masks a world of incredible energy and activity, a world that is actively advertising its secrets to the cosmos. The discovery that transformed our understanding of Enceladus came from a series of stunning observations by the Cassini spacecraft, which revealed a feature unique in the solar system: a series of colossal geysers erupting from the moon's south pole. These are not minor vents, but powerful, continuous fountains that spray water vapor, fine ice crystals, and complex organic molecules hundreds of miles into the vacuum of space. This spectacular plume, glittering in the faint sunlight, creates a dazzling display visible even from orbit. The eruptions are so powerful and voluminous that they are the primary source for Saturn's vast diffuse E-ring. Every particle in that enormous ring structure may have once been part of Enceladus's hidden ocean, blasted into space through a set of long, parallel fissures nicknamed tiger stripes. This discovery was a strategic game-changer in the search for life. While Europa's ocean is locked beneath miles of thick, impenetrable ice, Enceladus is actively ejecting the contents of its own subsurface ocean directly into space. The overall moon offering free samples of a potentially habitable environment. This realization prompted a daring and unprecedented series of maneuvers from the Cassini mission controllers. They redirected the billion-dollar spacecraft to fly directly through these plumes, a high-risk maneuver that involved passing through a stream of high-velocity particles. The gamble paid off spectacularly. Cassini's instruments tasted the chemistry of the plume, confirming the presence of salt water, silica nanoparticles, and a variety of complex organic compounds. The implications are staggering. The salt suggests a liquid ocean in contact with a rocky core. The silica is strong evidence for active hydrothermal vents on the ocean floor, environments analogous to the deep-sea vents on Earth, where life is thought to have possibly originated. And the organic molecules are the fundamental building blocks of life itself. Enceladus, therefore, presents a tantalizingly accessible target. The immense technological challenge of drilling through Europa's ice shell is not required here. A future mission could simply orbit Enceladus, collecting and analyzing the plume material to search for biosignatures, the chemical fingerprints of life. This has placed Enceladus on an equal, if not higher footing with Europa and Mars as a priority target for astrobiology. The material ejected from its interior contains all the known ingredients necessary for life as we know it. Liquid water, a source of energy from tidal heating and chemical reactions, and the right chemical elements. It has become one of the most fascinating and promising worlds ever discovered. A tiny moon that constantly and spectacularly announces its presence. Its shimmering jets, a beacon signaling the possibility of an ocean world alive with hidden energy and, just maybe, with life itself. At the very heart of the sprawling Jovian system, orbiting perilously close to the gas giant, lies a world that represents the violent antithesis to the cold, quiet promise of its neighbors. This is Io, the innermost of Jupiter's large Galilean moons, and it is a world of pure, unrelenting fire. It is not merely a world with volcanoes. It is a world that is a volcano. Its entire surface is scarred with hundreds of active vents, some erupting with such force they shoot molten fountains of sulfur and silicate rock for miles into the sky. These cataclysmic eruptions outshine anything ever witnessed on Earth, producing lava flows that can stretch for hundreds of miles, constantly repaving the moon's tortured surface. There is no ancient terrain on Io. Its entire crust is restless, a thin, fragile skin over a molten interior, reshaped again and again by flowing lava. No two views of its surface are ever quite the same. The engine driving this inferno is the same force that warms Europa's hidden ocean, tidal heating. But on Io, this process is amplified to an unimaginable degree. Io is locked in a precise orbital resonance with its neighbors, Europa and Ganymede. For every single orbit Ganymede completes, Europa completes 2, and Io completes 4. This clockwork rhythm is not a peaceful dance. It is a system of relentless gravitational torture. The regular synchronized tugs from Europa and Ganymede prevent Io's orbit from becoming perfectly circular, forcing it into an elliptical path. As it moves closer to and then farther from Jupiter, the immense gravitational stress flexes the entire moon, generating colossal amounts of frictional heat in its interior. This constant pumping of energy keeps Io's core and mantle in a perpetually molten state, turning the moon into the most volcanically active body in the solar system. This constant violent outgassing has profound consequences for the entire Jovian system. The volcanic plumes eject several tons of material, mostly sulfur dioxide, per second into space. This material doesn't simply dissipate. It is captured by Jupiter's colossal magnetic field, becoming ionized and forming a superheated donut-shaped cloud of plasma that encircles the planet. This feature, the Io plasma torus, is a dominant structure in the solar system, glowing faintly in ultraviolet light. It also makes the inner Jovian system one of the most dangerous places known to science. The torus traps and accelerates particles to incredible speeds, creating an environment of lethal radiation, thousands of times more intense than Earth's Van Allen belts. From a strategic standpoint, Io is therefore a profound paradox. It is a scientific goldmine for understanding extreme geology and planetary dynamics. At the same time, it is a formidable gatekeeper. Any future missions aiming to explore Europa or establish a presence in the inner Jovian system must contend with the deadly radiation environment that Io itself creates and sustains. Spacecraft must be heavily shielded, their trajectories carefully planned to minimize exposure. To stand on Io's surface would be impossible. The atmosphere is a tenuous, poisonous haze. The radiation would be instantly fatal, and the ground itself is a seething, shifting landscape of molten rock. Yet from afar, Io dazzles. It glows with the raw, fiery energy of a world forever in upheaval, a living furnace that actively shapes and defines its cosmic neighborhood. Orbiting beyond the chaos of Io and the icy promise of Europa is a world that defies simple categorization. It is a giant in its own right, a king among moons. This is Ganymede, Jupiter's largest satellite and the undisputed largest moon in our solar system. It is a titan among titans, larger than the planet Mercury, and so vast that if it were to break free from Jupiter's grasp and orbit the Sun on its own, astronomers would not hesitate to classify it as a full-fledged planet. But its size is not its most remarkable quality. Ganymede possesses a feature that makes it unique among all known moons. It generates its own intrinsic magnetic field. This is not a temporary, induced field, but a stable, self-sustaining magnetosphere, a planetary-scale phenomenon that sets Ganymede apart as a world of unparalleled complexity. This magnetic field is the unmistakable signature of a dynamic, living interior. Deep within Ganymede, scientists believe, lies a churning, molten metallic core, an engine of liquid iron that operates much like Earth's own. The existence of this core fundamentally alters our understanding of what a moon can be. It implies a world that has retained its primordial heat for billions of years, a world with a differentiated structure and active geology. Surrounding this core, evidence suggests a structure of almost surreal complexity, a cosmic sandwich of multiple oceans stacked between layers of high-pressure ice. Imagine descending through its crust. First a layer of ice, then a vast ocean of liquid salt water, followed by another layer of ice, and then perhaps another ocean below that. A layered architecture of water and ice reaching miles deep into its interior. This internal dynamism is reflected on its surface, which is a striking mosaic of two distinct terrain types. There are ancient, dark regions, heavily cratered and seemingly untouched for billions of years, a record of the solar system's violent youth. The overall moons are younger, brighter regions, marked by a mysterious network of long, parallel grooves and ridges. This grooved terrain suggests a period of immense geological upheaval in Ganymede's past, a time when its crust was stretched and fractured from below, perhaps by the expansion of its internal oceans. From a strategic perspective, Ganymede's magnetic field is its single most important asset. It acts as a powerful shield, a miniature magnetosphere that carves out a protective bubble within Jupiter's otherwise lethal radiation belts. While Io floods the Jovian system with deadly radiation, Ganymede provides a relative safe harbor, a world whose surface is significantly more protected than its neighbors. This makes it the most viable candidate for a long-term human or robotic outpost in the entire outer solar system. Its magnetic shield doesn't just protect the surface. It interacts dramatically with Jupiter's own colossal magnetosphere, generating shimmering curtains of light, auroras, that dance in the thin oxygen atmosphere above its poles. Ganymede, therefore, blurs the line between moon and world. It is a self-contained system with a molten core, a magnetic field, a tenuous atmosphere, and potentially the largest volume of liquid water in the solar system. It is a planet-class asset in orbit around a gas giant. When we look at it, we are reminded that moons are not merely passive companions or simple satellites. They can be as complex, active, and strategically vital as the planets they orbit, holding secrets of geology, magnetism, and potentially biology that challenge our very definition of what a world can be. Having journeyed through the fire of Io and the magnetic shield of Ganymede, we now return to our own celestial neighborhood to reconsider the silent companion we so often take for granted. The moon does far more than simply light our night sky or inspire poetry. Its steady, quiet presence is a fundamental pillar of our world's stability, a gravitational anchor that may have been the single most critical factor in the evolution of life on Earth. Without the moon, the planet we call home would be an unrecognizably violent and chaotic place, almost certainly hostile to the development of complex organisms. This assertion is a cornerstone of what is known as the rare Earth hypothesis, a theory which posits that while microbial life may be common in the universe, intelligent life is exceptionally rare, requiring a long and improbable list of cosmic coincidences. A large moon, like ours, is chief among them. Its primary function is that of a planetary gyroscope. Earth's axis is currently tilted at a stable 23.5 degrees, an angle that gives us our predictable, life-sustaining seasons. This stability is not a given, it is a gift bestowed upon us by the moon's immense gravitational pull. Without our moon, Earth's axis would likely wobble chaotically over geological timescales. It would swing wildly from one extreme tilt to another, plunging the planet into devastating globe-spanning ice ages, followed by periods of burning, unbearable summers. Mars, which lacks a large stabilizing moon, has experienced precisely these kinds of chaotic shifts in its past, drastically altering its climate. On Earth, such instability would have been a death sentence for complex life, constantly resetting the evolutionary clock and making the long, uninterrupted periods of climate stability necessary for intelligence to emerge impossible. Furthermore, the Moon acts as the engine of our oceans. Its gravitational pull stirs the seas, creating the rhythmic pulse of the tides. In the planet's early history, these tides were much more powerful and swept far further inland. Many scientists believe these vast, cyclical tidal pools may have been the perfect natural laboratories for prebiotic chemistry, concentrating the building blocks of life and nurturing the very first living organisms. In this sense, the Moon is not just a companion, but a guardian, a co-creator. It shaped Earth into a stable, predictable, and life-friendly home. Looking at it now, glowing softly above us, it is a humbling realization to think that its quiet presence may have been the essential prerequisite for our own existence. Yet the story of this guardian is born not of peace, but of an almost unimaginable violence. The leading theory of the Moon's origin, the giant impact hypothesis, is as dramatic as it is cataclysmic. Approximately 4.5 billion years ago, when our solar system was still a chaotic shooting gallery, a rogue protoplanet, roughly the size of Mars and nicknamed Theia, slammed into the young, molten Earth. The collision was not a glancing blow, but a world-shattering event of cosmic proportions. The impact was so powerful, it blasted a colossal plume of molten rock and vaporized debris from both bodies into orbit around the Earth. Over thousands of years, this searing hot ring of rubble gradually cooled and coalesced under its own gravity, eventually forming the Moon. The evidence for this violent birth is written in the very chemistry of the Earth and Moon. Rock samples returned by the Apollo astronauts revealed a striking isotopic similarity between the two bodies, suggesting they were forged from the same raw material. This cataclysmic event also fundamentally reshaped Earth itself. The immense energy of the impact likely tilted our planet's axis to its current angle, setting the stage for the seasons that the Moon would later stabilize. What we see as a calm, timeless presence in our sky is, in truth, the product of fire and chaos. It is the beautiful scar of Earth's traumatic early history, a fragment of our own world, blasted into space and reformed into its most faithful and vital companion. The Moon we see from Earth is a facade, a single familiar face presented to us through a quirk of gravitational physics. Due to a phenomenon known as tidal locking, our Moon rotates on its axis in precisely the same amount of time it takes to orbit our planet. The result is a perfect synchronization that keeps one hemisphere forever turned towards us and the other forever hidden. For all of human history, the far side of the Moon was a complete mystery, a blank map more unknown than the deepest oceans or the most remote continents. It was only in the 20th century, with the dawn of the space age, that this cosmic veil was finally lifted, revealing a world that was shockingly different from the one we thought we knew. The contrast between the two hemispheres is not subtle. It is a profound and stark gravitational schism. The near side, the face of the man in the Moon, is characterized by its broad, dark plains called Maria, Latin for seas. These are not oceans of water, but vast frozen seas of ancient volcanic basalt, the remnants of lava flows that flooded enormous impact basins billions of years ago. This is the Moon's volcanic past made visible, a smoother, darker canvas that defines its familiar features. The far side, however, is an entirely different world. It is almost completely devoid of these large maria. Instead, it is a rugged, brutal landscape, saturated with craters of all sizes, a relentless panorama of highlands that speak to a more ancient and violent history. Scientists believe this stark dichotomy is a result of the Moon's early formation. The far side's crust is significantly thicker, a geological feature that prevented the molten magma from the interior from breaking through to the surface. While the near side was being repaved by vast lava flows, the far side simply collected scars, preserving a pristine record of the early solar system's heavy bombardment. The quest to see this hidden face was a central chapter in the Cold War space race. In 1959, the Soviet Union's Luna 3 probe swung around the Moon and transmitted the first grainy, astonishing images of the far side back to Earth. It was a monumental scientific achievement and a staggering geopolitical victory, demonstrating a technological prowess that shocked the West. For the first time, humanity saw the second moon that had been hiding in plain sight. Today, the far side is no longer just a scientific curiosity. It has become the most valuable strategic high ground in the inner solar system. Its single greatest asset is that it is the most radio-quiet location accessible to humanity. Permanently shielded from the constant cacophony of radio transmissions from Earth, it is the perfect location for next-generation radio astronomy. A telescope placed on the far side could listen to the faint whispers of the early universe, the signals from the cosmic dawn, with a clarity impossible to achieve anywhere else. This potential has ignited a new 21st century space race, and this time China has taken the lead. In 2019, China's Chang'e 4 mission achieved what no nation had before, a successful soft landing on the lunar far side, a powerful statement of its rising ambitions and technological capabilities. This theme of cosmic rebellion, of bodies that defy the expected order, is not unique to our moon. Far out in the chilling depths of the solar system, orbiting the ice giant Neptune, is a moon that follows a path of defiance. Triton, Neptune's largest moon, does the unthinkable. It orbits backwards. While nearly every other major moon circles its planet in the same direction that the planet spins, Triton moves against the flow in a retrograde orbit. This strange trajectory is a smoking gun, undeniable evidence that Triton is not a native-born child of Neptune. It is a cosmic migrant, a captured wanderer. Astronomers believe it was once a dwarf planet, much like Pluto, that roamed the icy Kuiper belt before straying too close to Neptune and being ensnared by its gravity. This capture would have been a cataclysmic event, a violent gravitational struggle that would have destabilized and likely destroyed any of Neptune's original smaller moons. Today, Triton remains an oddball, an icy enigma. Its surface is a bizarre mosaic of smooth, freshly paved plains of nitrogen ice and terrain that resembles the skin of a cantaloupe. It is geologically active, with geysers that spout nitrogen gas into its thin atmosphere. But its backward orbit is also a slow-motion death sentence. Neptune's gravity is relentlessly tugging on it, dragging it ever inward. In the distant future, perhaps in 100 million years, Triton will cross the Roche limit, the point where Neptune's tidal forces will overwhelm the Moon's own gravity. It will be torn apart, its icy body shattering into billions of fragments that will form a magnificent, brilliant new ring system around Neptune. It will be a final, spectacular act for a world that has always been a beautiful outsider. The dramatic fate awaiting Triton is not an isolated destiny. It is a fundamental rule written into the laws of celestial mechanics. Moons that orbit too close to their parent planets live a precarious and often finite existence. They exist on a gravitational knife edge, constantly subjected to immense physical stress. The planet's gravity stretches and pulls at them, a relentless force that seeks to reclaim the material from which they were made. If a moon strays too close, it will cross a critical, invisible boundary, a point of no return known as the Roche limit. Within this zone, the planet's gravitational pull on the moon's near side becomes overwhelmingly stronger than the pull on its far side. This differential force, the same tidal stress that heats the interiors of Io and Europa, becomes an instrument of execution. If these tidal forces are stronger than the moon's own internal gravity holding it together, the moon will be ripped apart entirely. This is not a hypothetical scenario. We see the evidence of this process throughout the solar system, and we can predict its future victims. The most prominent candidate for this slow-motion destruction is Mars's small inner moon, Phobos. Already orbiting perilously close to the red planet, Phobos is slowly but inexorably spiraling inward, losing altitude with every circuit. In the deep future, perhaps 50 million years from now, it will cross Mars's Roche limit. At that point, the small moon will be unable to withstand the tidal stresses and will shatter into a cloud of rubble, its body disintegrating to form a spectacular, dense new ring around Mars. The long, deep grooves that already crisscross the surface of Phobos may be the first visible signs of this impending doom. Stress fractures appearing on a world that is slowly being pulled apart from the inside out. This process reveals a profound and cyclical relationship between moons and rings. They are two sides of the same cosmic coin. One can transform into the other. It is widely theorized that Saturn's magnificent rings, the most beautiful and complex structure in the solar system, may have been born from the death of one or more large icy moons that met this very fate long ago. In the chaotic youth of the solar system, some primordial rings may have clumped together under gravity to coalesce into new moons, while in other instances, moons were sacrificed to create rings. From a long-term strategic perspective, this process of creative destruction has significant implications. The formation of a new ring system around a planet like Mars would create both a navigational hazard for future spacecraft and a diffuse, easily accessible belt of resources. The remnants of the shattered moon would be spread out in a predictable orbit, a ready-made source of material for future construction or refueling operations. These cosmic cycles serve as a powerful reminder of how dynamic and fragile orbits truly are, even though they appear timeless and perfect to our fleeting human perspective. A moon is not a permanent fixture, but a body in a constant state of negotiation with gravity. Its existence depends on maintaining a delicate balance of distance and speed. For worlds like Phobos, that balance is failing. Its slow inward spiral is a countdown to its eventual demise, a final act that will transform it from a singular, solid world into a beautiful, glittering shroud encircling the planet it once faithfully served. Up at the frozen, dimly lit frontier of our solar system, in the vast and mysterious Kuiper Belt, orbits a system that fundamentally challenges our neat and tidy definitions of planet and moon. This is the realm of Pluto and its largest companion, Charon. For decades, Pluto was simply the ninth planet, and Charon its moon. But the arrival of NASA's New Horizons spacecraft in 2015 transformed our understanding, revealing not a simple master-servant relationship, but a balanced and intimate partnership unlike any other. Charon is not a minor satellite. It is a colossal world in its own right, measuring about half the diameter of Pluto itself. This size ratio is so extreme that the two bodies are no longer considered a planet and its moon by many astronomers, but rather a double dwarf planet system, the first of its kind ever to be explored up close. The key to this reclassification lies in their center of gravity. In the Earth-Moon system, the shared center of mass, known as the barycenter, lies deep within the Earth. Our planet wobbles slightly, but the Moon clearly and unambiguously orbits us. In the Pluto-Charon system, however, the barycenter lies in the empty space between them. They do not orbit each other. Rather, they both orbit this invisible shared point in the vastness of space. This is not a planet with a moon. This is a binary system, two worlds locked in a gravitational embrace, performing a slow, synchronized dance in the dark. From the surface of Pluto, Charon would not rise and set like our moon. It would hang motionless in the sky, a colossal, silent neighbor, forever presenting the same face as Pluto itself. This unique orbital dynamic has profound strategic implications for future exploration. The Pluto-Charon system is not a single destination, but a two-for-one opportunity. A single mission could establish a presence on both bodies with relative ease, using a sort of cosmic ski lift to travel between them with minimal fuel. This opens up possibilities for distributed infrastructure. A science outpost on Pluto could be powered by a nuclear reactor on Charon, with a communications relay between them providing a constant link back to Earth. The system acts as a natural pre-built space station in the outer solar system, a stable foothold in the resource-rich Kuiper Belt. The data from New Horizons revealed that these are not simple inert balls of ice. Pluto is a world of stunning geological diversity, with vast plains of nitrogen ice, towering mountains of water ice, and a thin, hazy atmosphere. Charon, for its part, is a scarred and dramatic world, dominated by an enormous system of canyons that stretches for over 1,000 miles and plunges far deeper than Earth's Grand Canyon. This colossal feature, nicknamed Argo Chasma, is evidence of a violent past, perhaps a time when a subsurface ocean froze and expanded, cracking the Moon's entire crust. The Pluto-Charon partnership, therefore, blurs the line between Moon and planet, forcing us to reconsider the hierarchies we impose on the cosmos. It demonstrates that in some cases, gravity binds worlds not into one-sided orbits, but into equal dances of mutual influence. The overall mood. They represent a new class of celestial architecture, a blueprint for how worlds can coexist as partners. A discovery that has redefined the very edge of our known solar system. Far from the inner solar system's familiar landmarks, in the cold blue-green twilight of Uranus's domain, circles a moon that appears to be a work of cosmic violence. This is Miranda, and at first glance, it looks like a world that should not exist. It is a chaotic, jumbled mess, a celestial Frankenstein stitched together from mismatched pieces. Its surface is a bizarre patchwork of terrains, where heavily cratered ancient plains abruptly terminate against younger, grooved regions, and vast, deep canyons slice through the landscape with no apparent geological rhyme or reason. It looks as though several different worlds were shattered and their fragments were carelessly reassembled. This small moon, one of Uranus's 5 main satellites, is a profound anomaly, a cosmic crime scene that offers a stark and unsettling window into the brutal history of planetary system formation. The most striking and famous feature on this fractured world is a geological monument of almost unbelievable scale, Verona Rupes. It is the tallest known cliff in the solar system, a sheer, terrifying escarpment that towers up to 12 miles high. To put this into perspective, if you were to stand at its edge, Earth's Mount Everest could be stacked 3 times below you and still not reach the top. On a world with such low gravity, a fall from this precipice would be a slow, surreal, and terrifying descent, lasting for more than 10 minutes before reaching the bottom. This single feature encapsulates the extreme and violent nature of Miranda's past. Such a structure should not be possible on a world so small. Its very existence demands an explanation of catastrophic proportions. The leading scientific theory for Miranda's bizarre appearance is as dramatic as the landscape itself. Astronomers believe that long ago, Miranda was struck by a colossal object in an impact so powerful that it completely shattered the moon, breaking it apart into a cloud of rock and ice. For a time, Miranda ceased to exist as a singular body. But the story did not end there. Under the relentless pull of its own gravity, the scattered fragments began to fall back towards each other. Over thousands of years, they reassembled, not into their original pristine form, but into the jumbled, chaotic patchwork we see today. The heaviest, densest material sank to the core, while the lighter ice and rock formed the fractured, mismatched crust. Miranda, in essence, is a world that survived its own death, pulled back from the brink of oblivion by the fundamental force of gravity. From a strategic and scientific perspective, Miranda is invaluable. It is a perfect, preserved laboratory for understanding catastrophic disruption events. In an era where planetary defense, the mitigation of asteroid and comet impacts on Earth, is becoming a critical global priority, studying a world that has already undergone a worst-case scenario provides priceless data. It allows us to model the physics of hypervelocity impacts, the dynamics of fragmentation, and the processes of gravitational reaccretion. Miranda is not just a moon. It is a data set on planetary resilience and destruction. Furthermore, its extreme and varied geology makes it a prime target for future robotic exploration of the outer solar system. The challenges of navigating its fractured terrain and scaling cliffs like Verona Rupes would push the boundaries of autonomous systems and robotic mobility. A mission to Miranda would be a definitive test of our ability to explore the most extreme and hazardous environments the solar system has to offer. It is a scarred survivor, a quiet, orbiting monument to cosmic trauma, carrying the deep wounds of its violent past as a badge of honor in Uranus's strangely tilted and mysterious realm. Though the moon appears to our eyes as a symbol of stillness and silence, it is a world that occasionally trembles. It is not geologically dead, but an active body with a complex inner life that reveals itself through seismic whispers. Seismometers left on the surface by the Apollo astronauts during their brief historic visits revealed a startling and unexpected truth. The moon experiences moonquakes. These tremors are not born from the grinding of tectonic plates as they are on Earth, but from a variety of more subtle and alien forces. Some are triggered by the immense tidal stresses exerted by Earth's gravity, which constantly kneads and flexes the moon's rigid crust. Others are shallow, thermal quakes, caused when the frigid lunar crust, chilled to hundreds of degrees below zero during the long lunar night, suddenly warms with the return of sunlight, cracking and shifting under the abrupt temperature change. Most mysteriously, however, are the deep moonquakes, which originate from far within the moon itself, their precise origins still not fully understood. When these quakes occur, the moon behaves in a truly bizarre fashion. Because its crust is utterly dry and rigid, lacking the water and magma that dampen seismic waves on Earth, the vibrations are not quickly absorbed. Instead, they echo and reverberate for an astonishingly long time. The entire moon rings like a colossal bell, with some quakes lasting for hours, a low, resonant hum that reveals the secrets of its internal structure. For scientists, this ringing is a priceless gift, a form of natural sonar that allows them to probe the moon's deep interior, mapping its crust, mantle, and core. For future lunar colonists, however, it represents a significant and persistent threat. Any permanent habitat, mining facility, or sensitive astronomical observatory must be engineered to withstand these long-duration, low-frequency vibrations, a unique architectural challenge not faced on Earth. This hidden energy, betrayed by the moonquakes, is mirrored by the discovery of hidden resources that have transformed our perception of the moon from a barren desert into a strategic asset of the highest order. Scattered across the lunar soil are countless microscopic glass beads, the shiny frozen droplets from fiery volcanic eruptions that occurred billions of years ago. Recently, scientists analyzing these tiny spheres made a landmark discovery. They contain significant amounts of water locked within their chemical structure. This is not the ice confined to the shadowed poles, but a vast distributed resource potentially available across much of the lunar surface. Though the moon looks parched and bone dry, these microscopic time capsules may store vast quantities of hidden moisture. The potential to harvest this water and extract its constituent hydrogen and oxygen, providing drinking water, breathable air, and, most critically, rocket fuel, is the central economic driver of the new space race. This principle, known as in situ resource utilization, ISRU, is the key to unlocking a sustainable human presence beyond Earth. Yet, the very soil that holds this promise also presents one of the greatest dangers. The lunar dust, or regolith, is unlike anything on Earth. When the Apollo astronauts returned to their lunar modules, they brought this fine gray powder with them, and inside the cabin, it gave off a distinct acrid smell they compared to burnt gunpowder. But all this was no ordinary dust. It is made of tiny, jagged shards of rock and glass, pulverized by billions of years of micrometeorite impacts. With no wind or water to wear them smooth, these particles remain as sharp as microscopic knives. This abrasive material is a relentless technological menace. It clogged equipment, wore down the seals on sample containers, scratched helmet visors, and even cut through the layers of the astronaut's spacesuit fabric. It is also a profound health hazard, as its fine, sharp particles are incredibly dangerous to breathe, capable of causing serious and permanent lung damage. To walk on the moon is to contend with a substance that is both a record of its ancient past and a persistent, insidious threat to any future mission that returns. The brief, audacious journeys of the Apollo era did more than leave footprints in the lunar dust. They established a permanent, albeit silent, human presence on another world. During their missions, astronauts placed a series of sophisticated scientific instruments on the moon, many of which continue to operate for decades, broadcasting data long after humanity had retreated to the confines of Earth's orbit. This network of experiments, known as the Apollo Lunar Surface Experiments Package, was a monumental achievement. A remote-controlled scientific outpost that studied the moon's interior, environment, and relationship with the Earth. Yet one experiment transcended all others in its simplicity and longevity. It is a set of mirrors called retroreflectors, and they are still in use today. From observatories on Earth, scientists routinely aim powerful lasers at these mirrors, measuring the precise time it takes for the light to travel to the moon and bounce back. The overall moon slowly drifting away from us, a cornerstone of modern celestial mechanics. But the retroreflectors represent something more than just a scientific tool. They are a quiet but profound geopolitical statement. As a piece of functioning infrastructure, they represent a continuous American scientific presence on the lunar surface for over half a century. In an age governed by the Outer Space Treaty, which forbids claims of national sovereignty on celestial bodies, the placement and continued use of such long-term equipment is a powerful assertion of leadership and a de facto claim on that specific territory for scientific utilization. Even now, as the moon sleeps under a silent sky, these instruments remain, gathering knowledge in the darkness, linking Earth and Moon with focused beams of light, and serving as quiet, glittering reminders of a time when humans first walked on another world. This theme of ancient hidden potential extends far beyond our own moon. Out in the cold realm of Jupiter, beyond the fiery furnace of Io and the shielded giant Ganymede, orbits a world that is a relic of deep time. This is Callisto, Jupiter's second largest moon. At first glance, it appears geologically dead. Its surface a dark, ancient canvas, scarred with more impact craters than almost any other world in the solar system. It seems to be a world frozen in time, a perfect record of the violent bombardment that characterized the solar system's youth. But precise measurements of its gravitational and magnetic fields, gathered by the Galileo spacecraft, suggest a truly astonishing secret. Beneath its cold, battered, and seemingly inert shell, Callisto may hide a vast salty ocean preserved in darkness for billions of years. If true, this makes Callisto a fundamentally different kind of ocean world from its sibling, Europa. Europa's ocean is kept liquid by active, intense tidal heating, making it a dynamic and restless environment. Callisto's ocean, if it exists, would be a place of supreme tranquility, warmed not by tidal friction, but by the slow, gentle decay of radioactive elements in its core. It would be a place where liquid water has endured in quiet stability while the surface above remained utterly unchanged. This makes Callisto a cosmic time capsule, a control group in the search for life. Its hidden sea, sealed beneath the oldest, most pristine surface in the Jovian system, might be as old as the solar system itself. In its profound silence, it could hold the secrets of stability, survival, and the long, slow endurance of water in the coldest reaches of space, offering a glimpse into a type of habitable environment entirely different from any other we have yet imagined. In the vast and diverse portfolio of Saturn's moons, there are worlds that are not merely strange, but seem to defy the very principles of natural formation. They are cosmic oddities, extreme outliers that push the boundaries of planetary science. One such world is Iapetus, a moon that looks like a deliberate work of art, a yin-yang symbol painted across the sky. One of its hemispheres gleams as bright as freshly fallen snow, reflecting nearly all the sunlight that strikes it. The other is stained as dark as pitch-black coal, absorbing light and heat with stark efficiency. This striking, two-toned appearance is not a subtle variation. It is a sharp, planetary-scale division that puzzled astronomers for centuries, ever since its discovery by Giovanni Cassini in the 17th century. For a long time, it was a mystery with no plausible solution. Today, the leading scientific explanation for this bizarre dichotomy is a story of cosmic contamination and a runaway thermal feedback loop. The theory begins with another, more distant moon of Saturn named Phoebe. Phoebe is a dark, carbon-rich body that sheds a constant, tenuous cloud of dust as it orbits. As Iapetus sweeps through this invisible cloud in its own orbit, its leading hemisphere, the side that faces forward, is perpetually sandblasted with this dark material, slowly accumulating a thin veneer of soot. But this is only the beginning of the story. This initial darkening creates a critical temperature difference. The dark, coated hemisphere absorbs more sunlight and warms up, while the bright, icy hemisphere remains frigid. This temperature differential triggers a runaway effect. Any water ice on the warmer, darker side sublimates, turning directly from a solid to a gas, and then migrates across the moon to refreeze on the colder, brighter hemisphere. Over eons, this process has stripped the dark side of its bright ice and deposited it on the bright side, making the dark areas darker and the bright areas brighter, amplifying the contrast to the extreme we see today. Iapetus is more than just a curiosity. It is a natural, planetary-scale experiment in geoengineering and albedo modification. It demonstrates in dramatic fashion how a simple change in a surface's reflectivity can fundamentally alter its climate and geology. This is not a theoretical model. It is a physical proof of concept with profound implications for future planetary settlement. Scientists and engineers have long proposed similar concepts for terraforming Mars. By spreading dark dust on its polar ice caps, we could lower their albedo, causing them to absorb more sunlight, melt, and release vast quantities of water vapor and carbon dioxide into the atmosphere. Iapetus shows us that this principle works on a cosmic scale. It is a lesson in planetary engineering written on a world 500 million miles away. Further out in Saturn's realm, we encounter an object so strange it barely qualifies as a moon at all. This is Hyperion, a world that looks like a colossal tumbling sponge. It is a small, deeply irregular body, pockmarked with so many deep, sharp-rimmed craters that it appears porous and hollow. Its low density confirms this appearance. It is not a solid body, but likely a rubble pile, a loose agglomeration of ice and rock barely held together by its own feeble gravity. But its appearance is not its strangest feature. Hyperion's rotation is utterly chaotic. Instead of spinning steadily on a fixed axis like a normal moon, it tumbles unpredictably through space as if forever losing its balance. Its orientation is never the same twice. Its rotational pole wanders randomly across its surface, making its motion completely unpredictable from one observation to the next. This chaotic state is a result of its irregular shape, its eccentric orbit, and the constant gravitational nudges it receives from the nearby massive Titan. Hyperion is another invaluable natural laboratory, this time for the field of planetary defense. Many of the most dangerous near-Earth asteroids are believed to be similar rubble piles. Understanding the internal structure and mechanics of such a body is critical for developing effective deflection strategies. A solid asteroid might be deflected with a kinetic impactor, but hitting a rubble pile like Hyperion could simply cause it to absorb the impact or break apart into a deadly cloud of fragments. Studying Hyperion's response to tidal stresses gives us priceless data on the physics of these loosely bound objects. Furthermore, from a resource perspective, Hyperion is a model for a new kind of mining operation. Its porous, low-gravity nature would make it exceptionally easy to excavate. Instead of drilling and blasting solid rock, future resource extraction could be as simple as scooping up loose, pre-shattered material. It is a cosmic sponge, adrift in orbit, a fragile and fascinating relic from the solar system's formation, forever tumbling in unpredictable ways that both challenge our engineering capabilities and inform our strategies for survival. The vast, silent darkness between the planets is not an empty void. It is a dynamic environment, alive with invisible forces and unseen energies that shape the worlds they touch. This cosmic weather is most dramatically revealed in the ethereal phenomenon of the aurora. We think of these shimmering curtains of light as a feature of planets, a celestial light show confined to worlds with thick atmospheres and powerful magnetic fields. Yet, auroras are not exclusive to planets. Some moons, bathed in the overwhelming magnetic influence of their parent worlds, glow with a faint, ghostly light of their own. This is more than a beautiful spectacle. It is the visible signature of a moon's interaction with its environment, a sign of complex physics at play in the deep cold of space. The most stunning example is Ganymede. As the only moon with its own intrinsic magnetic field, it creates a personal magnetosphere, a protective bubble that shields it from Jupiter's intense radiation. A natural male narrator with a warm, friendly tone. Just as charged particles from Jupiter's magnetosphere are channeled towards Ganymede's poles, they collide with its thin oxygen atmosphere, causing it to glow with faint but distinct auroral rings. Even moons without their own magnetic fields can sparkle, their tenuous atmospheres or icy surfaces lit up by the constant stream of charged particles racing through their planet's magnetic domain. While these ghostly lights may not be visible to the unaided human eye, the sensitive instruments of our robotic spacecraft can capture their glow, revealing a hidden layer of activity on worlds that appear inert. From a strategic perspective, these auroras are a critical intelligence indicator. They signal the presence of a magnetic shield, the single most important environmental factor for future long-term human presence. A world like Ganymede, with its self-generated magnetic field, offers a degree of natural protection from deadly solar and cosmic radiation that is absent on our own Moon or Mars. Any future outpost on Ganymede would be situated in a relatively benign radiation environment, dramatically reducing the mass and complexity of shielding required for habitats and extending the operational lifetime of both humans and equipment. The thought of a silent, airless moon crowned with an invisible storm of light is deeply haunting, but it is also a practical signpost, pointing to the locations that are safest for humanity's expansion into the solar system. It is a reminder that space is alive with unseen energy, painting even the smallest worlds with a color that signals safety and strategic value. This theme of hidden energy finds its most profound expression not in light, but in heat. According to the classical laws of thermodynamics, moons orbiting far from the Sun should be frozen solid, inert balls of ice and rock locked in a deep, permanent freeze. The overall Moon, and Enceladus, many are not. They harbor vast, warm oceans beneath their crusts, a paradox that has revolutionized planetary science. The secret to this impossible warmth is tidal heating. As a moon orbits a massive planet, especially in an elliptical path, it is relentlessly stretched and squeezed by the planet's gravity. This constant flexing generates immense friction deep within the moon's interior, producing a steady, reliable source of heat. This internal warmth can be powerful enough to maintain liquid water for billions of years, even under miles of insulating ice. This single discovery has shattered the old paradigm of the habitable zone, the narrow band around a star where liquid water can exist on a planet's surface. Tidal heating creates a new kind of habitable zone, a gravitational habitable zone, that can exist anywhere, even in the coldest, darkest reaches of interstellar space, as long as a moon is in the right kind of orbit around a massive object. Europa, Enceladus, and possibly Ganymede, Callisto, or even Titan are the prime examples in our own system, worlds where this process may be nurturing hidden oceans. This realization has fundamentally reordered our priorities in the search for extraterrestrial life. These underground seas are now considered the single most promising places to find it. Beneath barren, frozen surfaces, entire oceans may be stirring, warmed not by the distant sun, but by the steady, rhythmic pull of gravity itself. The implications are staggering. It suggests that the number of potentially habitable worlds in our galaxy could be hundreds or even thousands of times greater than previously imagined, with life thriving in the dark warmth of moons we once dismissed as frozen and dead. The very concept of a moon is inextricably linked with the idea of a vacuum. We picture them as airless, silent worlds exposed directly to the harshness of space. For the vast majority of moons, including our own, this is an accurate depiction. Their gravity is simply too weak to hold on to any significant atmosphere over geological time. Yet this is not a universal rule. In a stunning defiance of expectations, one moon in our solar system possesses an atmosphere so substantial that it surpasses our own. It might sound impossible, but Saturn's giant moon Titan is shrouded in a dense gaseous envelope, thicker and with a higher surface pressure than the air on Earth. To stand on its surface would be to experience an atmospheric weight about 50% greater than what we feel at sea level. This thick, soupy atmosphere, composed primarily of nitrogen with a smog-like haze of complex organic molecules, makes Titan a truly planet-like world. It is not a passive, static envelope of gas, but a dynamic system that allows for weather. Winds blow across its surface, clouds form and drift through its orange skies, and from them rain of liquid methane falls, carving rivers and filling vast seas. This alien weather cycle has sculpted a landscape that is both hauntingly familiar and deeply alien. But Titan's atmosphere is more than just a scientific curiosity. It is its single greatest strategic asset. It acts as a powerful, all-encompassing radiation shield, absorbing the deadly cosmic rays and energetic particles from the Sun that bombard the other worlds of the outer solar system. This natural protection makes Titan's surface, in some respects, a safer long-term environment for robotic and even future human missions than the exposed surfaces of our own Moon or Mars. Titan, therefore, offers a tantalizing glimpse of what a young, prebiotic Earth might have once been like, a frozen laboratory for studying the chemical pathways that lead to life. It represents a paradigm shift in our thinking, a reminder that moons are not just small, simple companions, but can host environments as rich, complex, and potentially life-bearing as planets themselves. This potential is precisely what drives the development of missions like NASA's Dragonfly, a nuclear-powered drone designed to fly through Titan's skies, leveraging its thick atmosphere to explore a multitude of diverse locations on this incredible world. While Titan represents the pinnacle of moon complexity, the solar system also hosts a menagerie of stranger bodies that seem to have been sculpted by a more whimsical set of rules. Pan, one of Saturn's innermost moons, is so bizarre it hardly looks real. It is shaped not like a sphere, but like a piece of cosmic ravioli or a miniature flying saucer, with a prominent bulging ridge wrapped around its equator. This strange form is not a random accident of formation, but the result of an ongoing process of construction. Pan's orbit lies directly within a gap in Saturn's A-ring, and its primary function is that of a shepherd moon. As it sweeps through the ring plane, its gravity clears a path, but it also continuously collects a stream of icy ring material that builds up around its middle, forming the distinctive equatorial wedge. Pan is not a static relic. It is a world that is actively growing, being built in real time from the raw materials of the ring system it helps to shape. The overall moon's Mimas, a moon that became an icon of popular culture for its uncanny resemblance to the Death Star from the film Star Wars. This striking likeness is a pure coincidence, the result of a colossal impact crater named Herschel that dominates one of its hemispheres. For decades, Mimas was seen as little more than a battered, frozen, and geologically dead chunk of ice. However, recent detailed analysis of its orbital mechanics has hinted at a shocking secret. The slight wobble in its rotation can only be explained by one of two possibilities. Either its core is strangely elongated like a football, or, far more excitingly, it hides a global liquid water ocean beneath its icy crust. If true, Mimas would be a new class of stealth ocean world, a place where a potentially habitable environment exists with almost no outward signs of its presence. It has transformed a familiar-looking moon into one of the solar system's most profound new mysteries, a prime target for future investigation. What once looked like a simple, inert body may in fact be a place of hidden warmth and untold biological potential. While the giant moons command our attention with their planet-like complexity, the solar system is also populated by a vast number of smaller, often overlooked bodies that harbor their own extreme and surprising features. Jupiter's inner moon, Amalthea, is a prime example. Small, lumpy, and irregularly shaped, it is a world of dramatic and disproportionate landscapes. Its surface is scarred by towering mountains and plunging valleys, some of which rise higher and cut deeper than Earth's own Mount Everest. Amalthea itself is barely 100 miles long, yet it hosts a topography of planetary scale, a testament to a violent history of impacts that have fractured and sculpted its surface. It glows with a faint but distinct reddish hue, a permanent stain from the constant rain of sulfurous material ejected by the volcanic fury of its neighbor, Io. From a future operational standpoint, a world like Amalthea presents a profound technological challenge and a unique opportunity. Its extreme terrain would be an ultimate proving ground for the next generation of autonomous rovers and landing systems, testing AI-driven navigation and mobility in an environment far more hazardous than the relatively benign plains of Mars. Far from Jupiter's chaotic inner court, in the cold and quiet outer reaches of its domain, drift entire families of irregular satellites that tell a different kind of story. Himalaya is the largest member of one such group, a dark, primitive body locked in a tilted, eccentric orbit that stands in stark contrast to the neat, circular paths of the Galilean moons. Himalaya is not a native of the Jovian system. It is a captured asteroid, a wanderer from the main belt that was ensnared by Jupiter's immense gravity billions of years ago. Its dull gray surface, lacking the bright ice of the inner moons, speaks to its origins in a different region of the solar system. These captured moons are more than just scientific curiosities. They are strategic assets of immense value. They are, in effect, free samples of asteroid material delivered into a stable, predictable orbit. For a future spacefaring economy, Himalaya and its brethren represent pre-positioned resource depots. A mission to mine an asteroid in the main belt is a complex multi-year endeavor. A mission to mine a captured asteroid in orbit around Jupiter is a far simpler logistical problem. These bodies are cosmic prizes, holding the same water ice and precious metals found in their free-roaming cousins, but conveniently located for future exploitation. The overall moons of the solar system we see today is the result of a violent process of migration, collision, and capture that reshaped entire planetary systems. While this history of chaos defines the outer moons, the inner regions can exhibit a clockwork precision that is just as astonishing. Saturn's tiny moons, Janus and Epimetheus, perform a celestial ballet of unparalleled grace. They share nearly the same orbit, a situation that should lead to an inevitable collision. But instead, every few years, as the inner, faster moon catches up to the outer one, their mutual gravity causes them to exchange energy. The inner moon is pushed into a higher, slower orbit, while the outer moon drops into a lower, faster one. They perfectly and flawlessly swap places. This rare and delicate dance, a stable pattern choreographed by gravity itself, is a natural model for orbital traffic management, offering profound insights for managing the increasingly crowded satellite constellations in Earth's own orbit. This state of perfect rhythm finds its ultimate expression in the most common state for large moons, tidal locking. For a body like our own moon, the constant gravitational pull of its planet has, over eons, slowed its rotation until it reached a point of perfect equilibrium, where its rotational period exactly matches its orbital period. The overall moon. This is not a cosmic coincidence, but the stable end state for most large moons. For humanity's future on our moon, this is not a limitation, but a profound strategic gift. Tidal locking creates predictable and permanent environmental zones. It gives us the peaks of eternal light at the lunar poles, where solar power is available almost continuously. And it provides the permanently shielded radio quiet zone on the far side. It is this gravitational stability that makes long-term settlement not just possible, but practical. As our understanding of the cosmos expands, so too does the language we use to describe it. The act of naming a newly discovered world is not a trivial exercise. It is an act of cultural appropriation, a way of imprinting human history and mythology onto the vast, impersonal canvas of space. For most of the solar system, we have reached back to the pantheons of ancient Greece and Rome, populating the heavens with gods and heroes. Yet, in the distant tilted realm of Uranus, a different tradition took hold. Its moons are not named for deities, but for literary figures, drawn primarily from the works of William Shakespeare and Alexander Pope. Titania and Oberon, the queen and king of the fairies. The tragic Ariel and the tormented Umbriel, the innocent Miranda. This unique tradition makes the Uranian system a cultural outlier, a remote celestial library orbiting a pale blue-green giant. It is as though this distant kingdom carries a collection of our own stories, a reminder that science and the humanities are not separate disciplines, but intertwined threads in our quest to understand our place in the universe. This intersection of science and storytelling finds its most profound expression on Titan, a world that may hold the key to life's oldest and greatest story. Its thick orange haze, a smog of complex organic molecules, hides a surface that may be a perfect mirror of our own planet's primordial past. Billions of years ago, before the first spark of life, Earth's own atmosphere may have been a similar chemical reactor, rich in the same organic compounds born from the relentless chemistry of sunlight striking simple gases like methane and nitrogen. Titan, in essence, could be a frozen, preserved snapshot of a prebiotic Earth, a planetary-scale laboratory that allows us to study the very chemical reactions that precede biology. On Earth, this complex chemistry eventually crossed a threshold and blossomed into life. On Titan, it may still be happening in its methane seas, or it may have stalled in the deep cold, forever poised on the brink of becoming biology. This potential is the driving force behind the multi-billion-dollar investments in missions like Dragonfly. It is a search not just for alien life, but for our own ultimate origin story. This potential for life, or at least its chemical precursors, transforms these distant moons from mere objects of study into locations of immense strategic value. As humanity begins to look outward with serious intent, moons are no longer seen as destinations, but as crucial stepping stones, logistical hubs in a future interplanetary economy. Our own moon, with its reservoirs of water ice, is the first and most obvious candidate for a permanent base, a cosmic equivalent of the naval ports that enabled the age of exploration on Earth. The water ice can be processed into rocket fuel, creating a refueling station that would slash the cost of missions to the rest of the solar system. Mars's tiny moons, Phobos and Deimos, could serve a similar purpose, acting as staging grounds and orbital docks for missions to the Martian surface, shielding spacecraft from the complexities of a direct planetary landing and ascent. Farther out, Titan's thick atmosphere offers unparalleled protection from radiation, while Ganymede's magnetic field provides another kind of natural shield. These are not just scientific outposts, they are the future choke points of interplanetary trade and travel. The nations and corporations that establish the first permanent infrastructure on these worlds will control the high ground of the 21st century, dominating the supply chains that will fuel humanity's expansion into the solar system. Even before we venture forth, we must acknowledge the profound and often invisible role our own moon has played in our survival. It is not just a stabilizer and a tidal engine, it is Earth's first line of defense. It acts as a cosmic shield, its scarred and battered face a testament to the countless asteroids and comets it has intercepted or deflected over the eons, objects that might otherwise have struck our planet. While it cannot stop every threat, its mere presence significantly reduces the frequency of catastrophic impacts, helping to maintain the long periods of climate stability necessary for life to flourish. Our planet's history would have been far harsher and our own existence far less certain without this silent, selfless guardian. In this context, the spectacular sight of a total lunar eclipse when the moon glows a deep blood red takes on a new meaning. This eerie transformation, which ancient cultures saw as a terrifying omen, occurs as the moon passes through Earth's shadow. The red light is the filtered glow of every single sunrise and sunset happening on Earth at that moment, projected onto the lunar surface. It is a moment when the shadow of our world, the world the moon protects, briefly paints its guardian in the color of fire and life. The clockwork precision of our solar system is a temporary illusion. The orbits we see today are not the ones these worlds were born into. Over the vast expanse of cosmic time, entire planetary systems are reshuffled in a slow, gravitational dance of migration. Giant planets born in the cold outer regions can drift inward toward their suns or outward into the void, their immense gravity wreaking havoc on the smaller worlds in their path. In this great reshuffling, moons are often the first casualties. Some are flung out of the system entirely, becoming lost, orphaned worlds wandering in interstellar space. Others are dragged along with their parent, only to be consumed, swallowed by the very planet they once orbited. The turbulent history of Neptune's system, with its captured rogue moon Triton, is a testament to this process. This reality of planetary migration fundamentally alters our search for habitable worlds beyond our solar system. The hot Jupiters we find orbiting perilously close to their stars are not natives. They are migrants who almost certainly destroyed their system's Earth-like planets on their inward journey. Yet destruction is not the only force at play. In the majestic realm of Saturn, we may be witnessing the opposite process, the birth of new worlds. Scientists now believe that some of Saturn's smallest innermost moons may have coalesced directly from its spectacular rings. In this glittering cosmic nursery, icy particles within the rings clump together under their mutual gravity, slowly growing into moonlets that sweep their orbits clean. Over immense timescales, they gather enough mass to become stable, independent moons, forever bound to the rings that served as their cradle. This process shows that moon formation is not just an event from the distant past, but an ongoing reality. Saturn's rings are not just a static spectacle, they are a living, dynamic system of creation. Whether ancient or newly born, moons serve as the solar system's most faithful historians. Their airless, uneroded surfaces are pristine archives, preserving the scars of every impact across billions of years. Some of these impacts came from comets, icy travelers from the deep outer system, carrying not just water, but the complex organic molecules that are the building blocks of life. When these comets slammed into the early Earth, our planet's active geology and weather erased the evidence. But on the Moon, or on the icy surfaces of Europa and Ganymede, the chemical traces of these cosmic deliveries may still be preserved, frozen and untouched. These worlds are forensic records, holding the secrets of how our planet was seeded with the ingredients necessary for life. This pristine, preserved nature is also reflected in their internal structure. When the Apollo seismometers detected moonquakes, they revealed that the moon rings like a giant bell, its vibrations echoing for hours through the dry, rigid crust. This eerie resonance is a direct consequence of its violent formation. The giant impact that created the moon was so energetic it baked out nearly all the water and other volatile compounds, leaving behind a structure that is fundamentally different from Earth. This dryness, confirmed by the ringing, has profound implications for future lunar construction, which must account for a seismic environment unlike any other. This portfolio of unique worlds presents humanity with a set of profound strategic choices. Titan, with its thick atmosphere and methane seas, is the ultimate prebiotic laboratory, a place to understand our own origins. Enceladus, with its tiger stripe fissures constantly erupting samples of its ocean into space, offers a low-cost, high-reward target in the search for life. It is a world actively advertising its secrets. And then there is Europa, the grand prize. Its hidden ocean, containing more water than all of Earth's seas combined, represents the single most promising habitat for extraterrestrial life in our solar system. But it is a prize locked away beneath a thick, impenetrable shell of ice. Reaching it will require a technological leap on par with the Apollo program itself. And woven through all these futures is the constant, quiet reminder of celestial mortality. Moons are not permanent. For worlds like Phobos, slowly spiraling inward toward Mars, their destiny is already written, a final, cataclysmic act of destruction that will transform them into the raw material for a new ring. The solar system is a place of constant birth, death, and transformation, and its moons are the primary witnesses to this epic, ongoing story. The architecture of our solar system is not a random assortment of objects, but a structured hierarchy of influence. In the outer realms, giant planets reign supreme, their immense gravity capturing and corralling vast families of moons. Many of these distant, irregular satellites are not native-born children, but cosmic migrants, captured objects from the Kuiper Belt, the vast, frozen frontier of our solar system beyond Neptune. Triton is the most famous of these captured worlds, a former dwarf planet now enslaved in a backward orbit. But it is not alone. Dozens of smaller bodies follow similar paths, their strange orbits a permanent record of ancient migrations and violent captures. These captured moons are more than just historical curiosities. They are pristine, deep-frozen samples of the primordial material from which the solar system was formed, delivered into a convenient orbit for future study and resource extraction. They are cosmic fossils, telling a story of a dynamic, chaotic past, where planets and moons traded places and entire systems were reshaped. While these distant wanderers represent the largest scale of lunar diversity, the solar system is also populated by a vast number of smaller bodies that blur the line between a moon and a simple space rock. Mars's moon Deimos, for instance, is a lumpy, potato-shaped object barely 12 kilometers wide, more akin to a captured asteroid than a proper world. Jupiter and Saturn host dozens of these tiny, irregular satellites, some less than a mile across, lacking the mass to pull themselves into a sphere. These miniature moons are the leftover building blocks from the birth of the planets, cosmic rubble that was preserved in orbit rather than being swallowed or shattered. At the opposite extreme are the giants that rival planets in size and complexity. Jupiter's Ganymede is larger than Mercury, while Saturn's Titan has an atmosphere thicker than Earth's. These colossal worlds host their own magnetic fields, weather systems, and complex geological processes, fundamentally challenging our definitions of what a moon can be. This incredible diversity extends to their very environments. The coldest temperatures ever measured in our solar system were not found on distant Pluto, but inside the permanently shadowed craters at the poles of Earth's own moon. Here, in a darkness that has persisted for billions of years, temperatures plummet to an almost unbelievable 410 degrees Fahrenheit, colder than the surface of any planet. These cold traps are the perfect environment for preserving water ice, turning the Moon's most frigid and inhospitable locations into its most valuable resource depots. Conversely, some moons shine with a brilliance that can cast shadows in the blackness of space. Saturn's Enceladus, its surface constantly repaved with fresh, clean ice from its geysers, reflects almost all the sunlight that hits it, giving it a dazzling, ghostly glow. This high reflectivity, or albedo, is a direct indicator of geological activity, a shining beacon that signals the presence of a living, breathing world beneath the ice. Perhaps the most poignant legacy of our first ventures beyond Earth is also the most fragile. When the Apollo astronauts stepped onto the Moon, they left behind crisp, clear footprints in the soft lunar dust. With no wind, no rain, and no atmosphere to erode them, these footprints, along with rover tracks and discarded equipment, will remain perfectly preserved for millions of years. They are silent monuments to a singular moment in human history, a permanent yet incredibly delicate archive of our species' first steps into a larger world. They serve as a quiet reminder that the Moon is now not just a natural satellite, but a place of profound historical and cultural significance, a museum that holds the first faint traces of humanity's cosmic journey. The story of the moons is not a closed book. It is a narrative that is still being written, with new chapters unfolding in real time. Around the gas giants, particularly within the shimmering, complex laboratory of Saturn's rings, we are witnessing the very process of creation. Astronomers have identified small, nascent moonlets, infant worlds being born as icy particles clump together under their own gravity, slowly sweeping their orbits clean. This is not a story from the distant past, but a present-day reality. We are watching, in real time, a scaled-down version of planetary formation, a process that provides an invaluable model for understanding how planetary systems take shape across the galaxy. This data is not merely academic, it is mission-critical intelligence that will guide our search for exoplanetary systems and help us identify the telltale signs of worlds in the making. This cycle of creation is mirrored by a history of profound destruction and resilience. Moons live violent lives, and collisions can shatter them completely. Yet, gravity is a patient and powerful force of reconstruction. A world like Miranda, which appears to have been shattered and then reassembled from its own fragments, is a monument to cosmic survival. It is a case study in catastrophic disruption, offering priceless data for the emerging and critical field of planetary defense. By studying these broken and reformed worlds, we learn how bodies respond to hypervelocity impacts, how they fragment, and how they can pull themselves back together. This is not just history, it is a blueprint for survival, informing our own strategies for mitigating the threat of a catastrophic impact on Earth. Despite these incredible insights, the origin stories of many moons remain profound and tantalizing mysteries. While we understand the broad strokes of capture, co-formation, and giant impacts, the specific details for many worlds remain elusive. The precise mechanics of our own moon's formation are still debated, with new theories challenging the classic giant impact hypothesis. This uncertainty is not a failure of science, but a sign of its honesty. The overall mood raises a question of immense existential importance. Is the specific configuration of our Earth-Moon system, a large planet with a single, massive, stabilizing moon born from a cataclysmic impact, one of the universe's great filters? Is this rare arrangement a critical, non-negotiable prerequisite for the development of intelligent life? If so, then solving the mystery of our moon's origin is not just an academic exercise. It is a vital step in understanding our own rarity and our place in the cosmic order. As we peer beyond our own system, this sense of mystery only deepens. Astronomers are now on the cusp of a new era of discovery: the detection of exomoons, moons orbiting distant planets around other stars. While none have been definitively confirmed, the evidence is mounting. Theories suggest these worlds could be stranger and more diverse than anything we have ever imagined. Earth-sized moons orbiting gas giants in the habitable zone, water worlds with global oceans, or tidally heated volcanic moons like a super Io. The search for exomoons is the next great frontier. The first confirmed discovery of a potentially habitable exomoon will be a Sputnik moment for the 21st century, a scientific and cultural milestone that will ignite a new wave of exploration and technological development. Ultimately, as we look across our solar system and gaze toward others, a fundamental truth emerges: planets rarely travel alone. Moons are not afterthoughts. They are integral, essential components of planetary systems. They create tides, stabilize climates, feed rings, and provide magnetic shields. They are the partners, guardians, and children of the worlds they orbit. And so, our quiet intelligence briefing among these worlds comes to a close. We have journeyed from our own moon, now a place of history and future ambition, to the hidden oceans of Europa, the fiery volcanoes of Io, and the hydrocarbon seas of Titan. We have seen moons that are being born and moons that are slowly dying. Each one is a reminder that the universe is not a collection of isolated objects, but a deeply interconnected system of systems. As you drift towards rest, let your thoughts circle these quiet worlds. There is no need to hold on to the details, only the feeling of vast, silent potential. The night sky is full of whispers, and the moons tell the story of where we came from and where we are going next. Our strategic survey of the solar system's moons concludes here, but the story is only just beginning. We have journeyed from the familiar, scarred face of our own moon, a world of ancient history and near-future ambition, to the far-flung, enigmatic systems of the ice giants. We have analyzed worlds of fire and worlds of ice, moons that are being born from glittering rings, and moons that are slowly being torn apart by the relentless pull of gravity. What emerges from this grand tour is not a simple catalog of celestial objects, but a complex and interconnected strategic landscape, a new frontier with its own resources, choke points, and geopolitical imperatives. The old perception of moons as passive, secondary bodies is now obsolete. They are primary actors on the cosmic stage, holding the keys to the future of human expansion, scientific discovery, and perhaps the answer to our oldest question: are we alone? The central theme of this new paradigm is in situ resource utilization. The discovery of water ice, not just on our moon, but on countless other bodies, is the single most important economic driver of the 21st century space race. This is not about water for drinking, but water for fuel. The ability to mine ice and convert it into rocket propellant on site fundamentally breaks the tyranny of Earth's gravity well. A lunar or Martian orbital economy powered by locally sourced fuel becomes not a distant dream, but an achievable, near-term engineering goal. Moons like ours, and even small bodies like Phobos and Deimos, are no longer just destinations. They are the strategic refueling depots, the deep space naval bases from which all future exploration will be launched. The nations and corporations that control this infrastructure will control the arteries of interplanetary trade. Beyond resources, moons represent the ultimate strategic high ground. The lunar far side, permanently shielded from Earth's radio noise, is the most valuable piece of real estate in the solar system for the next generation of radio astronomy, a place from which we can listen to the faint echoes of the Big Bang itself. Ganymede, with its intrinsic magnetic field, offers a natural radiation shield, making it the most logical and safest location for a permanent human outpost in the entire outer solar system. Titan, with its thick atmosphere and complex organic chemistry, is not just a scientific target, but a potential long-term haven, protected from the harsh realities of open space. Establishing a presence in these locations is the modern equivalent of seizing a vital port or a strategic mountain pass. It is an assertion of presence, capability, and long-term intent on a scale that will define the coming centuries. These worlds are also our most profound laboratories. In the plumes of Enceladus, the hidden ocean of Europa, and the methane seas of Titan, we have the opportunity to search for a second genesis of life. The discovery of even a single microbe on one of these moons would be the most significant and transformative event in human history, a moment that would forever recontextualize our place in the universe. It is a prize of such magnitude that it justifies the immense cost and risk of the missions now being planned. And as we continue to study these diverse and often violent worlds, the shattered and reformed Miranda, the captured Triton, the doomed Phobos, we gain priceless, practical knowledge. This is not abstract science. This is the data that will fuel our planetary defense models, helping us to protect our own world from the ever-present threat of a catastrophic impact. As our briefing concludes, let the sheer scale of this new reality settle. Let the details fade, leaving only the feeling of a vast, interconnected system. A quiet universe of worlds in orbit, each holding a piece of the puzzle of our past and a key to our future. The night sky is no longer just a collection of distant lights. It is a landscape of opportunity and challenge, of profound mystery and immense potential. The story of the moons is now our story, and the next chapter is waiting to be written.